This is the second in a series of short technical videos about Hammerspace Tier 0. In the previous video, I showed how to configure Tier 0. In this one, I'll demonstrate how data flows through the system. After a quick review of the environment, we'll write a file into the Hammerspace share. Then we'll peek under the covers to see how the file landed on the storage. Next, we'll fail one of the nodes and show that despite the failure, the data is still accessible. Finally, we'll show that the system automatically recovers from the node failure by protecting the data on an additional surviving node. This is the demo setup. Remember, each compute node is exporting its local NVMe storage via NFS v3. These exports are configured into Hammerspace as storage volumes. The storage volumes are paired into 4 availability zones simply by including the prefix AZ in the volume name in Hammerspace. Instances of files in our Hammerspace share /data can be placed on any of this storage based on the configured objectives. Let's look at those objectives now. Keep in mind that there are many different ways to use objectives to control data placement. This is just one example. These are the objectives set on the data share. Objectives can be set on a share, directory, or even an individual file basis. The objectives include availability 5.9s, which induces Hammerspace to create 3 instances of every file. Because we defined availability zones, each instance will be placed into a different availability zone. But that's not all. Hammerspace knows when there's a local Tier 0 volume, and it will automatically place one of the file instances there. So in summary, when Node 1 writes a file into the /data directory, one instance will land on the Node 1 Tier 0 volume, and additional instances will be created in different availability zones for protection. Now that you understand what's supposed to happen, let's write a file and see that the expected behavior occurs. I'm here on Node 1 in the mounted Hammerspace /data share. Let's create a file. And now let's look in Hammerspace to see what happened. The green circle here under alignment means that Hammerspace has finished aligning the file to the objectives. Hovering here, we can see that 3 instances of our file exist. One was placed on Node 1's Tier 0 volume, and the others were placed on Tier 0 volumes in different availability zones. That's great. Now let's fail Node 1's storage volume and see how Hammerspace adjusts. First, we need to make the volume unavailable. Now I'll tell Hammerspace the volume has failed and isn't coming back. I'm at the Anvil CLI here. And we can see in our client that the file remains available. When the volume failed, Hammerspace realized our file was no longer aligned with the availability 5.9's objective, and it created another instance to bring it back into alignment. The file still has 3 instances, but now they're on nodes in availability zones 2, 3, and 4. That's all for this one. In the next video, we'll run some performance tests on Tier 0. Thanks for watching.